Welcome back, guys, to this month's episode of the Funtastic Academy. Today, we learn about a new type of memory latch, a circuit that stores memory in a much simpler way for external code and circuitry to interact with. I'm talking, of course, about the D Latch, a device that is so simple to understand, a bit more complicated to create, yet ubiquitous in all CPUs in the world. So, how does it work? That's what we're going to dive into today. Now, in a short bit, I'm going to transition to Computer Ayush, who, wearing a slightly different red shirt, will explain how the D Latch works. But before that, let's talk about last episode's quiz question. The answer to the question of what's the more common way of storing memory with capacitors is dynamic RAM, or DRAM for short. I hope we get to cover DRAM in a future episode because it's where most of your computer's memory comes from and it's really important to understand. But let's dive in back to Computer Ayush to discuss about the D Latch. Computer Ayush? Thank you so much, Canva Ayush. So now it's over to me, Computer Ayush. In the last video, we built this circuit, an SR latch, in Circuitverse, this beautiful online simulator that I love so much. So the idea of an SR latch is that it has two inputs, set and reset. By turning on the set input, you permanently make the output 1. Now, no matter what you do to the set input, it will remain as output 1. The only way to reset it back to 0 is by using the reset input, which will reset the output to 0. And now you can do whatever you want to the reset input, and the output will still remain as 0. But this is kind of clunky. How will we use this in a real circuit? Say we made some logic system that will take some number, take another number, add it using maybe our ripple carry adder or potentially a look ahead carry adder, like we mentioned in the previous episodes. And this arithmetic unit would be used to add the two numbers or do some calculation. Then, how do we feed it back into this to remember it? If it's a 1, we will have to turn on this bit. But if it's a 0, we'll have to turn on this bit. This is some complicated circuitry, and we'll have to add this every time we need to store a bit of data. So instead, what we can do is embed that complicated circuitry into the circuit itself. What I'm going to do today is make a circuit called a data latch, or D Latch for short. Now, the idea of the D Latch, which you can see I've already renamed it to D Latch here before the class, to just show you and give a quick spoiler on what it's going to be. We just simply have one input up here for what value we want to input. Another input down here will tell us whether we want to remember that value or forget it. So if we just plug this to a ground voltage, 0, then no matter what we do to this, the output will not change and the gates will have remembered what we put in. So let's try making a D latch. Now, the thing that will turn our SR latch into a D latch is a component called the demultiplexer. You don't need to know what demultiplexer does, but basically what it does is if we turn on a 1 here, it will route our input here. But if we turn a 0, it will route it down here. Depending on what we turn this on, it will be routed to any number of different gates. And we only need to route the input if the store signal is on. If store signal is 0, forget it, no need. So we just add some simple gates. We will turn on the set input if the data we want to store is 1 and we actually want to store the data in the first place. We will turn on the reset input if the data that we want to store, if we want to store the data, but we data that we want to store is not 1. So we actually want to reset the data. Now I have finished this. These 3 gates are all we need to make a simple demultiplexer. Now if I turn this on, we won't see any change in the output because the store signal is off. If I turn on the store signal, we now have a 1. I'll turn off the store signal and interfere with this, but nothing's happening. Now if I turn on the store signal again, while this is 0, we'll have stored a 0. So we can plug in any number here, and if we want to store it, it will be outputted on the output end. So this D Latch is a very useful circuit. There's one issue though. This D Latch actually is too fast. You might wonder how a circuit being too fast could possibly be an issue. So I'll explain that. Now let's say we add a quick another circuit and call it a calculator. Now I can insert my D Latch into my calculator. This is our data signal and this is our store signal. Now, let's say we want to store a 1 into the D Latch. So we still have 1 with the store signal 1, and our output, if we plug it out, is 1. I'll turn off the store signal and disconnect this wire and nothing happens. Now, what we want to do is just do a simple calculation on the 1 bit that we have stored in our memory. What calculation we want to do? Well, we just want to take the inverse of it. So what I'll do is take a NOT gate. Now in circuit verse, typically you're doing calculations from left to right. And in my mirrored video, it's coming opposite, but left to right. So what that means is that this is the default direction the gates go. But you can easily just flip that and it's going the other way. So now what we can do is we find the opposite of the NOT, the value we've stored in our D Latch. The 0. Wait, we've stored the 1 in our circuit and we now have the opposite of that, which is the 0, also stored. Now, what if we want to store this 0 back into our D Latch so that we can remember that the opposite of the value we stored here is 0? We'll plug it in. Nothing happens because our store signal is 0. When I turn this on, we will have stored 0 back into our circuit. And this will now become a 0. 3, 2, 1, crash, 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 crash. As you can see, there's this error that pops up at the bottom. There's actually an infinite cycle that's happening. Our circuit is repeating on itself and it breaks and everything is crashing. But why? What's the issue here? Well, we're storing a 1. The NOT of 1 is 0. We are storing a 0. Then instantly, we calculate that the NOT of 0 is 1. We store a 1. The NOT of 1 is 0. Store a 0. NOT of 0. And this keeps on repeating. So we end up getting an 8-footed loop whenever we turn on. And because this is a digital circuit, instead of everything catch on fire, we just see this simulation stack limit exceeded. So we need a different type of circuit, one that can wait until new updates can come, one that only updates the signal when a certain event happens. Introducing my best friend, the clock. The clock is this wonderful little circuit that keeps on oscillating between a 1 and a 0. And in circuit verse, if you just click on the project properties, you could change the speed of the clock. So we can make it twice as slow. Or I could make it 2 times as fast as it was originally was. But we're not going to be using the automatic clock circuit here. We are going to use a handmade clock signal. So we'll just have an input being our clock and get oscillated 1 and 0 by hand. What we want our clock to do is essentially only update the data we have when our clock is a 1. When it's 0, don't do anything. That will solve our problem here, right? If we set the value to 1, the value will update once, but then it won't update again. You have to turn it to 0 and then turn it back to 1 again for the re-update. So we could essentially control when our clock re-updates. Now, this is the pie in the sky idea. If we had a clock signal which could tell our circuit when to wait, that would be amazing. But how would you design that? You would need to design a latch which could check the clock signal every microsecond to see whether it's turned from a 0 to 1. That would be a huge design issue, right? Well, tune in next time to the Funtastic Academy where we do work on it. So next episode, we'll be working on this clock and see what wonderful things that it brings us. But now, back to Ayush. Thank you, Computer Ayush. Back to me, Ayush here. So, what did we learn in this episode? To recap, we learned about the issues within SR latch, how we can solve it using the D Latch's inbuilt demultiplexer. But we also saw that some issues arise when we try to connect a D Latch based register back onto itself. So, in the next episode, we're just going to discuss about clocks, a potential solution to this issue. But since we've already spoiled that we're talking about clocks, I leave you with this quiz question. What is the unit of speed that clocks are measured in? If I say a clock is spinning at the speed of 1, is it 1 what? Seconds? Miles? What units are used to measure a clock? Tell me the answer by next episode. I'll see you next time on the Funtastic Academy. Bye!